Hi my friends, today we model this interesting mechanism for drawing a parabola by using dynamic simulation. Finish simulation, and if you take a look here, there are two subassemblies and a part. This is one subassembly. Better I select here, which is the fix component. This is the central drawing mechanism, and this is the pen for drawing the parabola. Here you see the main structure subassembly and the pen, and here you see the central drawing mechanism, which is the other subassembly. Let's create the main structure. New, standard millimeter IAM, place, and we place firstly the basic frame. Place grounded at origin. As you already know, we place this in position for actual Inventor instead of Inventor 2014. We apply set current view as home, fit to view, and we see now this placement of the first object. Other components are the guides 1, 2, and the feet 1, 2, 3, 4. We apply constraint for applying this guide. I go to this face with insert. I select this and I place it right here. Apply. Now we can rotate this as we want. Normally it must be aligned with this. We use constraint angle first solution between this edge, which has the arrow oriented to the right, and another one oriented to the right, this one. Yes, 0 degrees, which are here. Apply. Same for the other guide. We select this to be placed here. Wrong. Cancel. Constraint. The other hole must be selected for this point, for this placement, and you see everything is okay, but you can rotate it. So we apply this and we continue with angle between this face and this face. Okay, then constraint insert for the feet. this face placed here. Apply. This to be here. Apply. This is here, and the last one is right here. Oh, cancel. The last one is to be placed here. Okay, now we have a component which is a subassembly, and we save it as MS, main structure. Save. Okay. Close this, and I create another subassembly which is which starts with this bar, place grounded at origin. I don't say many words because you know what I do here. Set current view as home, fit to view. I add components. Place slider central, which is this one. I place it with its axis to the axis of the first bar cylindrical. Apply. Place slider end. Constrain axis on axis. Apply. Now I want to see all of them with edges to be more visible. Place again, and we add slide the rectangular. We constrain it as insert with this circle and axis on this circle or this, no problem which you select. Apply. Next is the central slider here. We place it by selecting this face and this face. You see mate is the constraint. Apply. Now you can see that we didn't made any contact between this face and this face. Now, in order to apply dynamic simulation, we must avoid redundancies. You see, this plane and the upper were together in contact. How many degrees of freedom have we fixed here? We fixed 3 degrees of freedom. Now if I make contact between this and this, I force other 3 degrees of freedom to be fixed. This is why I select only this line, this edge, to be in contact with this face. Apply. Now here we have 5 from 6 degrees of freedom applied. To continue, I'll apply a temporary restriction. I use constraint, angle, first solution between this plane and a plane from the origin, an work plane, which is XY. Okay, now we can move components. We can rotate this, but we cannot rotate this one, even if it is placed on the axis, and it has that possibility, but because of the last constraint we cannot do this. Okay, we place now the spacer somewhere here, and if you take a look here, this is smaller than this. I apply constraint with the insert between this circle axis to this circle axis. You see, this is larger than this one. Apply. The other component is shaft threaded, this one. I place it using the same constraint, insert, between this circle axis to this circle axis. Okay, I can rotate very easily, and I use also the mouse because I use a special device. It is called Space Mouse from 3D Connection, and you can see more by watching the tutorial number 180. We place now the 4 bars, flat bars, 1, 2, 3, 4 bars or levers, and we use insert to select this circle face and place it right here. Apply. How many degrees are taken here? 5 degrees, because the only possible movement is rotation. You see? I continue by adding the only metric 8 nut, because I have to place it with insert here. Apply. Good. Now I place another component, which is the shaft spacer. It comes somewhere here. constraint, insert this circle axis, place here, apply. We use the same insert for placing another lever to this circle, apply. Now we have to think about the next move. You see, this lever can only rotate about this axis. So, since this can be rotated and moved, I'll place this axis over this axis, but not insert. You cannot move up or down this one. So we don't need to place a constraint on this direction. Good. Constraint axis to axis. This axis over this axis. Okay. Now you see here it goes right on the face. Even if I didn't impose contact face to face, I can hide this for a moment, and you see this position here, and when I place it back, visibility, you see that it is placed in position. We try to place as little as we can the number of the constraints. I don't think we can reach the perfection, but we try. You will see what happens when we go to dynamic simulation. Now it is possible everything, and the system works, but for dynamic simulation we have to respect these conditions. Another lever is this one, and we place it right here. Okay. The other contact is axis to axis. Yes, we place it on this axis, and we force the movement of this central slider, yes, to be coincident with this axis. Let's do this. Mate, first solution, axis on axis. Okay. We also add constraints, insert, and this lever comes here, apply, then mate for axis to axis, axis to axis. Okay. Now we have to place nuts, but I prefer to continue with modeling the assembly, and we'll add later that nuts here, here, and so on. I don't forget to eliminate the restriction constraint for this lever or slider, central slider. This angle must be suppressed, and now we can rotate this and it goes in the space, of course, you see. Okay. We save this as the second subassembly with the name CDM from Central Drawing Mechanism. We have MS, main structure, subassembly, and now we place the other one. Okay, close. We create another assembly by placing this MS grounded at origin. We place again the proper position, set current view as home, fit to view. Now we have a stable and a nice position. We add that CDM assembly, this is the other, and we also add the Stedler head. Place here. In Romanian is cup and I didn't change the name from 2014. Good. The first constraint is an insert between this circle axis to this hole from the fixed grounded subassembly. Apply. This Stedler head comes here. Okay. All we can do now is to rotate this second subassembly about this axis. We cannot change positions here, nothing but rotation. To have access to movement, to all movements, we make this CDM as flexible. Very important. Now I can apply movements here, as you can see. We place this end in the channel, in this channel. Constrain this edge to be placed in contact with that edge. Okay. Now we have movements here, as you can see. This was grounded in its state. And now I eliminate that grounded because we want to have movements together of all components. Take a look. Yes. Now I have to place this central slider in the starting position. That starting position is when it goes here, but in our procedure we have to use only one point for this, not the face, not a line, because we create not good constraints. I double click this object. Now you see I have access to the subassembly, and I repeat double click here to have access to the part central slider. Then I place a work point on this corner. Now you have to see that point. Yes, it is right here. Good. I go back from part to subassembly, and I go back from subassembly to assembly. Now you see that point. Constrain. I select the point, only the point, and the face. Oh, I selected an axis. Not good. Constrain, point, and face. You see, now this face is aligned with this face. Okay. We'll use that point in the next stage, dynamic simulation. Environments, dynamic simulation, and we have here a message about redundancies. You can ignore this by applying don't show this message again. Everything is working. But for the perfection of mechanisms, it's good to apply repairing redundancies. Okay, I admit now this. You see where are the problems. Here and here. I click on one of them, for instance this one, and I apply mechanism status with or without this detail. You see here, from this 6 degrees of freedom, rotate about Y axis is not needed. You see here what are the axes. This is Z, X, Y, Z with green is one object. The objects are connected here between this axis and this slider, and there is a problem here. Rotation about Y. Y is this with 2 arrows. We can solve the problem by modifying the subassembly. Go back from this dynamic simulation, go here, double click, and we know that here is an insert, but it must be not an insert but an axis, a mate between the axes. You can try to solve all these problems, I am sure. Okay, I go back to dynamic simulation, I accept this, and we try to create the movement. But before, we have to eliminate this constraint to have this face same level with this face. We go back from the environment and dynamic simulation, and we take a look to this assembly, and we select the constraint, which is that one, and we suppress this constraint. Good. We go back to environment, dynamic simulation, and we try to see if we can move the system. I click here, I keep pressed click, and I move a little. Yes, okay. Now I have to apply a force to have a source of movement. That force must be applied in a location. The location is that point you already know. Inventor waits for a line with the other direction, and the value of this force is 0.01 Newton. Okay. Now I apply run, and you see the movement starts. Okay. Then I apply here 4.2 seconds, and I add a trace for this endpoint to have a graphic here. Okay, start. You see that we have here 1 second, and this was the time downloaded and is known for dynamic simulation. We have to apply the run to replay the simulation. Now Inventor collects data for all the movement. I go back, and we don't have any other stop at 1 second. Everything is known. If you save this dynamic simulation, you will have all of the data. If you don't save, you lose that data and you have to run again. Good. Now we can add the nuts. We open the CDM assembly and we place two nuts of metric 6, 1, 2, and we place them with the insert in position. Apply and apply. Then the other 5 nuts of metric 5. 1, 2, 3, 4, 5. 5 to 5. Constrain. Insert. And here. Apply. Another one goes right here. Apply. Apply. And the last one is right here. Okay. Save. Okay. And now we are sure that we can update, global update, to place them in position. You see, they are all over. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones include the previous ones. That's all for today. Thanks for watching. Bye bye.